Hello everyone, I'm a university professor engaged in AI research. We are standing at a very fortunate, historic moment. Human knowledge and civilization are about to experience explosive growth. I am delighted to share my observations on the new generation of artificial intelligence and its impact through a series of videos. Today, let's talk about coding capabilities of major LLMs, not from benchmark testing, but our feeling and experience while applying them. In the more than 2 years since their inception, large language models have made tremendous progress in programming capability. A constant stream of new models emerges, yet improvements in one domain are often accompanied by regression in other zones. Phenomenon tied to the intrinsic architectural patterns of the models. Our research aims to fundamentally enhance certain core characteristics of these large models. Below are observations on several leading models. DeepSeek. This is a model with a significantly smaller parameter scale and much lower training costs. Remarkably, it sometimes outperforms both ChatGPT and Claude on certain logical reasoning problems. However, DeepSeek tends to become disorganized during iterative code revisions, often resulting in programs that grow increasingly complex and messy. Claude, arguably the strongest programmer among current large models, its tendency, however, is to produce excessively verbose code, frequently overcomplicating the logic. Furthermore, it can be resistant to changing its approach even after repeated feedback. ChatGPT. Its latest version shows significantly enhanced programming ability and likely generates code the fastest at present. It suffers from a serious flaw: a high frequency of hallucinations, readily inventing non-existent functions or APIs. When challenged, it may defend itself by claiming the output was merely a conceptual level example. This is particularly problematic in complex project development. Grok. Upon its debut, it demonstrated the strongest cognitive and reasoning capabilities. Recently, however, it seems to have fallen behind in programming. It likely directs more effort toward modeling the physical world, such as supporting Tesla's autonomous driving and robotics research. Directions that are undoubtedly important. Gemini. It has made strong recent advances, with scores rising significantly on many benchmarks. Google appears to have a tendency to over-optimize for benchmark performance or training, which can come at the cost of practical usability. Additionally, its response speed is currently relatively slow. Our past research has found that some of Google's excellent transformer models, while performing very well on benchmarks, can see their performance degrade much faster than baseline models when the operational context changes. Therefore, in practice, a cross-use strategy for these models can help us better handle programming tasks. Another important technique is to constrain the LLM's output. For example, instructing it to output only the changed lines or functions. This is an effective method for reducing the impact of hallucinations. We have developed our own substantial understanding regarding the generation and mitigation of hallucinations. Only a small proportion of professors still engage in hands-on implementation in AI. I am one of them. For this new breed of AI that is fundamentally different from its predecessors, the large language model, frequent programming, and debugging provide a more tangible, first-hand perception of its characteristics, its problems, and the construction of solutions.